So here's the second video on law of sines. The first one you watched on the Khan website, and now we're going to look at some practical examples with law of sines. First, I just want to review the law of sines. You don't have to have a right triangle to actually solve all parts, find all angles, find all sides of a triangle. We can actually use the law of sines. So if you haven't already, print out worksheet T6, and we will fill some of this in together, and then the rest will be work for you to do. So let's just remember what the law of sine says. It says if I have the sine of angle A over side A can be equal to the sine of angle B over side B is equal to the ratio of the sine of angle C over side C. Notice the sides are in lowercase letters and the angles are in capital letters. Okay, so as we get into this, and we are gonna get to solving examples, but I first want to remember what we know about triangles from geometry. Remember, we used to prove congruent triangles using side, 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 side angle, side. We did all of that in geometry. So let's just review that real quick. Side angle side. We abbreviated it as side angle side. And it was when we had a triangle and we knew one side, we knew an included angle, and we knew another side. Side, included angle, side. So if you want to write any notes, I would say the included angle between two given sides. Side, side, side was another one. We just knew three different sides of a triangle. Angle, 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 abbreviated AAA. Here we knew three different angles of, can't see angle, angle. We knew three different angles of a triangle. Side, angle, side. Angle, side, angle. Angle, side, angle. Here we have an angle. We have an included side, and we have another angle. Angle, included side, and another angle. So if you want to write any notes here, I would write given two angles and the included side. The included side means the side between the two angles. Angle, angle, side, AAS, means I have two angles and a side. But notice this side is not included. Just like the example before, I had two angles, but the included side, this is two angles and a non-included side. Two angles and a non-included side. And the last one, just as a review, we had side, side, angle. So here I know two sides and an angle. But this is an angle that is not included. So I know two sides and a non-included angle. Two sides and a non-included angle. So law of sines, as Khan went over, can be used on only some of these types of triangles. So tomorrow or the next day, we are going to look at side angle sine, but that actually can only be used with the law of cosine. And so we'll look at those tomorrow. Same with side, side, side. Law of cosine. Angle, angle, angle. If I don't know any measurement on the sides, I can't figure out the size. So this triangle cannot be solved using law of sine or law of cosine. So none of the above. And the last three, though, all three of these can be solved with law of sines. Now, if I have a triangle that's angle, side, angle, that will give me one possible triangle. If I have angle, angle, side, that will also give me one possible triangle. The goofy one, the one that's a little bit more challenging, was when I have side, side, angle. That's when I can either have no triangles, one triangle, or two triangles. So we're going to look at those in just a minute. So which triangles can be used to solve with law of sines? we can either have angle, side, angle, 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 side, or side, side, angle. So here the first one is any time you have two angles and the measure of any side. For actually both of these, you have two angles and the measure of any side, you can use the law of sines. Two angles and the measure of any side, you can use the law of sines. Or anytime you have the measure of two sides and the angle opposite one of the sides. So here you have two sides and you have the angle opposite one of the sides. Those are the times you can use law of sines. So let's just look at a little example before we get into really delving into side-side angle, which is the challenging one. So here we'll draw some triangle, call it A, B, C. A we'll say is 40 degrees, side C we'll say is 20, and angle B we'll say is 60 degrees. Okay? So here I first identify what one is this. This is angle, side, angle. Angle, side, angle. So that means if I look back from my front sheet, angle, side, angle, there is one possible triangle. One possible triangle. So if there's one triangle, I just go ahead and use my law of sines to find all the missing pieces, solve the triangle. So here I would have the first thing really I'm going to do is find C, because if I know two angles in a triangle, I can easily find the third angle because I know triangle sum. So all angles have to add up to 180. 60 plus 40 is 100. 180 take away 100 would give me angle C to be 80 degrees. So that was easy. And now we can actually use law of, so that's one of my answers. Now I'm going to use law of sines to find the other two sides. So we have sine of 80, angle C is 80, over 20 equals sine of 40 over little a. I'm going to solve first for little a. I'm also going to solve for side B. I'm going to put a little b, little b, little a is what I need to solve for. So the second one we'll set up sine of 60 over little b is equal to sine of 80 over 20. Okay, so this is what I'm going to solve. I'm going to find little a and I'm going to find little b. So I grab my calculator. I'm going to make sure I'm in degree mode, and I am. So to solve this, we get a times sine of 80 equals, we're just cross multiplying, 20 times sine of 40. To get a alone, I have to divide both sides by sine of 80. So a is going to equal, well, let's do the math. 20 sine of 40 divided by sine of 80, and a equals 13.1 if I'm rounding to the nearest tenth. Alright, do the same thing for b. I'm not going to show all the steps, but we would take 20 times sine of 60, 20 sine of 60